Welcome back to it. It's Maths Masterclass with Leo. Today we are doing inverse Laplace transform. Don't forget to like, subscribe, and share the content with your friends. So today we're treating questions using the table. Right, the first question that we have, it is the Laplace or the inverse Laplace of 1 over s squared plus 9. Right, so when you look at this question, it's related to this sine of 80. Why? It doesn't have s. This is s here. So for it to be cos, it must have s. It can't be this because it has squared. It can't be sine because it's negative, right? This one is positive. It can't be cos because it doesn't have s. So make sure you check that. If it's positive, it's related to cos and sine, but it can't be sine because sine has a numerator of s. Can be 7s, can be 5s, can be 10s. That is related to what? To your cos, right? So you can easily see that inverse Laplace of what? From this, inverse Laplace of a over s squared plus a squared. This is equivalent to sine of 80, right? How do we make sure that our numerator and our value of a are equal, right? Or how do we make sure that our numerator is equal to the value of a? So the first thing that we have to do is to rewrite this 9 in terms of exponents, which will be 1 over s squared plus 3 squared, right? 1 over s squared plus 3 squared. Then after doing that, I can write my numerator should always, in this case, should be equal to 3, right? So how do I do that? How do I make sure my numerator is equal to 3? I'll say this will be the Laplace inverse of 1 over 3 multiplied by 3 over s squared plus 3 squared, right? You can see that if I cancel this and that, it brings me back there. If I cancel 3 and 3, it brings me back there. So this mathematically is like I've done nothing, right? And then I can take out this 1 over 3 and say this will be 1 over 3 Laplace inverse of 3 over s squared plus 3 squared. Now I have my numerator is 3 and the value of a is also 3. Then I can just say, look at this. This is a sine of 80. This will be 1 over 3 sine, where there's a, substitute 3t. This is your solution, right? This is the solution when you're looking for the Laplace inverse of 1 over s squared plus 9. Right? Let's get another question. Second question, we're looking for the Laplace inverse of 5 over 3s minus 1. Right? We're looking for the Laplace inverse of that. Looking at this, it doesn't have squared. So it should be this, related to that. Right? It doesn't have squared. So it's related to that. So now, means the first thing is I have to make sure that my coefficient of s is 1. My coefficient of s is 1. So this will be the Laplace inverse of 5 over 3, taking out the common factor, s minus 1 over 3. Right? What did I do? I made sure that the coefficient of s is equals to 1. Then I can take out this 5 over 3 outside, which will give me 5 over 3 Laplace inverse or inverse Laplace of 1 over s minus 1 over 3, right? Then I can definitely see that now it's really something like that. So it means I'm going to get my solution is e, or 5 over 3e to the power what? 5 over 3 e to the power negative. Is it negative? No, positive in this case. Positive 1 over 3t. Right? That is my solution. That is what I'm going to get when I'm looking for the Laplace inverse of 5 over 3s minus 1. Let's go to the next question. Next question, let me just try to erase here. Next question. Okay. So it is easy to understand Laplace inverse when you understand the introduction of Laplace, because it's just the reverse of what we've been doing. We've been going forward by using Laplace transform. Now we're going backward using the inverse Laplace, right? This is here and there. Okay. Okay. Don't forget to like, subscribe, and share the content with your friends. Right? If you have a question, you can just drop it on your comment section, and then I'll try to address it. Okay. The next question, it is the Laplace inverse of 6 over s to the power 3. S to the power 3. Let me just try to write the proper bracket. Right? Now, when you look at this, when the power of s, or the power of s, or the exponent of s is 3, this means the value of n is equals to 2. Right? Why? Because we are using this. Right? We're using this property. If the value of the power of s is 3, means the value of n is 2, right? Then you can use this. So this will be, if you look at this, it simply tells you the Laplace inverse of n factorial over s to the power n plus 1. This is equals to what? This is equals to t to the power n. Right? That is equal to t to the power n. So in this case, if you look at this, how can I change that? How can I make sure that this, I have 2 here? Because I can see that the value of n is 3. I mean, the value of the power of s is 3. It means the value of n is that. So this, it means, is Laplace inverse of 3 multiplied by 2 factorial over s to the power n, or s to the power 2, right, plus 1. That is how it is, plus 1. That is how it is, right? And then I can take out this. This will be 3 Laplace inverse of 2 factorial over s to the power 2 plus 1, right? When I look at this, let me just make sure my factorial is visible. When I look at this, it is that. It is this, right? It is that. So now this will be 3t squared. That is my solution. That is my solution, right? Now let's get to the next question. The next question, you are given the similar question, just differs a little bit. Okay. In the meantime, don't forget to like, subscribe, and click the bell icon so that you get notified whenever we upload content that is related to your studies. Right? So the next question, they want to know the inverse Laplace of 3 over s to the power 4. Right? We can definitely see that this is s to the power 4. If s is to the power 4, it means n is equal to 3. Right? Such a way that the Laplace transform of what? Of this 3 factorial over over s to the power 3 plus 1. Right? But what is 3 factorial? This is like 3 times 2 times 1. Then 3 factorial is equal to 6. So here we will have the inverse Laplace of 6 over s to the power 4. Right? But I can change this. I can change this to be like that. It should be like that. So how did it get to that? It means they said the inverse Laplace of what? Of 2 multiplied by, not 2, but 1 over 2. Right? When I say 1 over 2 multiplied by this, I'm going to get what? This is s to the power 4. Right? That is how it is. Now, this I can take it out, which will be 1 over 2 inverse Laplace of what? T to the power, what is t to the power 4? T to the power 4, this will be, okay, 6 over s to the power 6, to the power 4. This is like 1 over t to the power 3. Right? 1 over t to the power 3 is our solution. Now, let's try to get 1 or 2 more questions and close it. Okay, inverse Laplace is easy as that. As easy as that. Okay. Okay. Now, lastly or second last, I have the inverse Laplace of 7s over s squared plus 4. Right? Looking at this, I can take out the 7 and have 7 Laplace inverse of what? Of s over s squared plus, this can be 2 squared. Right? 7, and then when I look at this represents cos. Right? It represents cos. Then it means this will be 7 cos of 2t. That's my solution. That was easy. Let's check the next one. Laplace inverse of 4s over s squared minus 16. Right? And then when I look at this, I can take out this 4. This will be 4 Laplace inverse of s over s squared minus 4 squared. Right? This is related to cosh. If you look at cosh, there. Right? Then my solution will be 4 cosh or hyperbolic cos of 4t. That is my solution, or my inverse Laplace of 4s over s squared minus 16. Right? Let's take the last one. This is the last one for the day. Let me erase here. Okay. Now the last one, it says the Laplace inverse of 3 over s squared minus 7. Right? So, because of the negative, it's related to shine. Right? It doesn't have s on top, that is why I'm saying it's related to shine. Then, how can I make sure that my numerator and this are equal? How can I do that? The first thing that I can see, this, I can rewrite it as Laplace inverse of what? Of 3 over s squared minus square root 7. Square root of 7. Right? And then, the Laplace inverse of, if I want to remain with this 3, how can I do that? How can I make sure that, okay, I want to make sure that this and this are the same. How can I do that? How can I make sure that they are the same? I can cross multiply by 3 over square root 7, and then this will be square root 7 over s squared minus square root 7. Right? This and this can cancel, and they bring me back to that. Easy. And then I can take out this 3 square root 7 outside, and then Laplace of what? Square root 7 over s squared minus square root 7. Right? Then this, I can now come back and say this is shine. This will be 3 over square root 7 shine or hyperbolic sine of what? Square root 70. That is the solution. Don't forget to like, subscribe, and share the content with your friends. See you in the next video. Tango means thank you. Tango!